Okay, tell you what. I will provide. No, forget it. I won't provide you. I'm not gonna put that work in there. Forget it. Okay, fine. I'll let you have. You see this 8 by 11? You cut this in half, and then you put your formulas on half of it. Okay, one side. 2 sides considered cheating. Okay, put your formulas on a half 8 by 11. Okay, next class. Okay, if you do it the day after, no cheat sheet. Okay, all right. All right. Next class, right? Yeah. No. Forget it. Okay, here we go. Let's move on. Okay, here we go. Record. Okay, this one here. 01 goes to bat. He takes 10 hits, right? What's the probability he get 8 hits and 2 misses, right? So therefore, this will be 10 choose what? Okay, 10 choose 8. Can I go 10 choose 2 instead? Yes, because 10 choose 8 the same thing as 10 choose 2. Yes or no, everybody? Okay, I choose 2 of you and I don't choose 8 of you. The same thing as I choose 8 of you and I don't choose 2 of you. That makes sense? Okay, equals to 0.3 the power of what? It hits it 8 times, so the 8. And then there'll be 0.7 to the power of 2. Okay, so this could be an answer. That could be answer 2. Okay, makes sense? Okay, next one. Yeah, sure. Okay, chapter 9? Chapter 9. Let's do it later on. Chapter 9. Okay, number 10 with all the graphs. This same assignment? This one here? 7 and 8. 7 and 8, right? No.
8, 9 this test.
Oh, it's 8 and 9?
Yeah.
Oh, sorry, 8 and 9. That's right. Okay, fine. 8 and 9. Okay, my bad. Okay. Which one do you want to go over, Shreya? Which one? Review number 1, 2, number 3, review number 1. First one, this one here? This one? Okay, let's do it. Okay, here we go. Okay, which one you want to go over? 16. 16. Is it 16 is okay, is it this one? Whoops. Okay, this one. Oh, sorry. This one here. Okay, here we go. Let's do this together. Okay, number 16. Here we go. I thought there were answers to these. Did I not put them up? Oh, it's okay. Okay. All right. I think it was like either Maya or CC, right? Yeah. Okay. So local radio station plays 40 rock and roll songs during each 4-hour show. Okay, so 40 songs. Okay. The program director at the station needed to know the total amount of airtime for the 40 songs so that he can also program during the show for news and advertisements. Okay. So distribution of the length of the rock songs in minutes is roughly symmetric. So roughly symmetric with a mean of 3.9 and a standard deviation of 1.1 minutes. Okay. This over here is the mean and the standard deviation for what again? For each one song. Okay with that? Okay, so hey, let me put this down. Number 1, the mean for a single song is about 3.9 minutes. And the standard deviation of a single song is equal to 1.1 minutes. Okay, is it normally distributed? Do we know that actually? Okay, it's just we just know it's roughly symmetrical. Okay. So in a way, assume it's. Okay, describe the sample distribution of the mean of the length of songs for the random sample of 40 rock and roll songs. Okay, so this is for 1. Number 2, what if I want to find the mean for 40 songs? What do I do with this number? Times over 40. So 3.9 times over 40 gives you, is it 700 and something? What is it? Times 4, 3.156? 156? You sure? For okay, 40 songs altogether. Yeah, the sampling distribution for the mean of okay, hold on. Okay. My bad. Sampling distribution for sample size is 40. Okay, sample size is 40. Okay, first question. If I have a sampling distribution of 40 songs, what is the mean of this going to be? It will also be 3.9 minutes. Okay, my bad. Everyone okay with that? What is the standard deviation for the mean of 40 songs? It'll be 1.1 divided by square root of 40. And then what you need to write down is also number one, the sampling distribution of X bar should be what? Normally distributed because of the central limit theorem, because n is greater than 30. Yes or no? Does it matter what the population distribution is? No. Okay, number one. And then what else do you need to know? Yeah, describe it, right? It would be normally distributed with a mean of 3.9. You also need to write that okay, in words, okay? With a standard deviation of whatever this is equal to. Yes or no, everybody? Okay. What does B ask you for? Can I see? B goes, B goes, if the programmer schedules, okay, hold on. Shh. Okay, here we go. All right, look at this one together. B. Okay, B, let's look together. Okay, if the programmer schedules 80 minutes of news and advertisement for the 40-hour, which is 240-minute show, only 160 minutes are available for music. Approximately, what is the probability that the total amount of time needed to play the 40 songs exceeds the available amount of time? So what's asking you is, okay, if you have, let's say, yeah, you only have what, 160 minutes? Okay, let's just do this anyways, okay? If the mean for one song is equal to 3.9 minutes. Now, for this part, it's up to you how you want to do it. You can do the average of each song, or you can do the total of 40 songs. Either way, the probability will stay the same, okay? What's the mean for 40 songs again? So 156 minutes. Okay, so far? The standard deviation for one song was equal to 1.1 minutes. What's the standard deviation for 40 songs? And remember, can you add standard deviations? No. What can you add instead? So variance, right? So therefore, this will be 1.1 squared multiplied by 40. And then what do you do afterwards? Square root it, and this will give you what? 6.96 minutes. Yes or no, everybody? And then this over here, okay, if you look at the central limit theorem, it should also be what? Normally distributed, okay? So what you do then is this. Here's your graph. This is 156. Okay, that's the mean. Standard deviation is 6.96 minutes. And then you're looking at the probability it'll be what? 160 minutes or more, right? So what do you use then? Normal CDF. And then A will be 60, 90 to 99. So what's missing? 160. Good. Making sure you guys pay attention. Okay. And what's the next one? 156. And then your standard deviation is 6.96. We'll go over there. And that will give you the probability. Option number one. Yes or no, everybody? Okay. Option number two. Let's say we decide to do average. Average, okay? Now you're given how much time? 160 minutes. Can you go 160 divided by 40? And how much time for each song? 4 minutes per song, right? So basically doing the same thing is, what if the average song takes more than 4 minutes? So you can also go normal CDF. What is A and what is B again? So 4 minutes, yeah. 90 to 99, good. And what goes here? 3.9 is correct. And what goes in here? Over what? Remember, to do this one here, you're not looking at the population distribution. What are you looking at? The sampling distribution. Therefore, it'll be 1.1 over what? Square root of 40. Okay? On your calculators, find out what this one is, find out what that one is, and tell me whether if I use the average or the total, will they give me the same answer or different? Okay, go. Lydia, okay? Sure. Which one is it? Which one before her? Okay, can you just finish this quickly and tell me if it's the same thing? And then your question is what number what? What from which homework is it? Like You have a title name for the PDF file? It's all over here. 8.1 chapter 8 review. I don't know if I have that. Is it 8? This one? This one? Okay, look at that. Yeah.
It's just this exact one to the table.
Is this one? Oh, okay. This one here. Okay, I didn't see that. Okay, sorry about that. Okay, this one here. Let's look at it together. Okay, this one. Here we go. Yeah. And you also want to go with number 14? Okay. Okay, suppose you toss 2 fair dice. Let me cut these down. 2 fair dice. So you have 1 coin over here. No, 2 fair, that coin. 2 fair 4-sided dice. Okay, I've never seen a 4-sided dice. Just imagine it's actually something real, okay? So you have a 1, 2, 3, and 4. Yeah. Say it again. A 4-sided dice? Okay. Good for you. Oh, okay. Yeah. The triangular pyramid, right? Okay. Okay, thank you. So awesome. Here's 1 dice, and then 1, 2, 3, and 4. There's another one. Okay, let X represent the average of the 2 sides that are facing up. Okay. So when it lands, how do you have a side that's facing up? Okay, let's just pretend. Let's pretend we're living in a world where it's like 2-dimensional and 3 dimensions do not realistically exist. Okay, it says which of the following is a sampling distribution of X? You ready? Okay, shh. When I do these questions, okay, there's 2 ways to do them. 2 ways. You decide which one you want. Ready? Okay. First option is what's the mean of this? Okay, easy way. Number 1. First option is you make a dice chart. 1, 2, 3, 4. 1, 2, 3, 4. How many options are there all together in total? 16. You guys okay with that? Okay, and then you're getting the average. You have a 1 and 1. What's your average? 1. You have a 2 and 2. What's your average? 2. This is also 3, and this is also what? 4. You have a 2 and a 1. What's your average? 1.5. You have a 3 and a 1. What's your average? 2. You have a 4 and a 1. What's your average? 2.5. You guys following what's going on so far? What's this one right away? 1.5. What's this one, and that one right away? 2.5, 2.5, and 2.5. What's this one here? 2. This one, both what? 3. And then this one and this one is what? 3.5 and 3.5. This will be all the outcomes you can have when you get the average of these 2 dice. Okay? So what you do next is this. You have 2 lists, L1 and then you have L2. What do you put in L1? What are the outcomes you can have? You can have a 1. What else? 1.5. And then what else? 2 and 2.5. And then a 3. And then a 3.5. And then also what? 4. Okay. L2 will be the frequency or the probability of each one. What's the probability getting a 1? 1 out of 16. Okay. You know what you can do? If time is like, a bit like you're short in time, what I usually do is this. Just put down 1, 2, 3, 4. 3, 2, 1. Okay with that? And then after that, for L3, I just go L2 divided by what? 16. Yes or no, everybody? Okay, so that means it automatically gives you 1 over 16, 1 over 16, 2 over 16, and then 2 over 16, and then 3 over 16, and then 3 over 16, and then 4 over 16. Yes or no, everybody? Okay, random variable X. I'm going to go 1 variable calc. What goes in here? L1 for your random variable. And what's the other one? L3. And that will give you mean and also your whatever it is you get. Make sense, everybody? Option number 1. Who understands this? I'll give you 1 minute to do it quickly, and I'll show you the second one. What's asking you for? Oh, okay. It's not asking for anything else. Well, in that case, we're done then. What is it? What's the mean and what's the standard deviation of the distribution? Right? And if you want the mean and standard distribution, you have to use a chart. Okay? Okay. Yeah. One variable calc. Okay? Now that's one way of doing it. Okay? I have a second way. Second way is you use chapter 7 random variables. Okay? For example, if you need to find the mean, you would do this. The mean of the first one is you find the mean of this. 4 plus 1 plus 2 plus 3 gives you what? 10. So this will be 10 over 4, which is what? 2.5. And the mean of the second one is also what? 2.5. If you're getting the average of them, what you do is, let's call this like mean, like the mean of Z. The Z is the average. So you got to take the first one, you add the second one, and then divide by what? 2. They're both 2.5. You add them both and divide by 2 gives you what? 2.5. Okay with that? And then if you're given the standard deviation over here and the standard deviation over there, and then what you're doing is, if I'm looking for the standard deviation of Z, what do? Remember, you cannot combine standard deviations. What can you combine instead? Variance. So find the variance of the first one, find the variance of the second one, and what do you do afterwards? You square root this, but the problem is doing averages. So what do you gotta do now? Divide by 2, and that will give you the standard deviation of the next one. Make sense? Okay, Lydia, okay with this? Okay, Mark, I want you to do it first because he's been like same page. Pick what number? This one over here? Okay, here we go. 102.
101.
101. Okay, let's do it. Okay, here we go. Shh. Just so you know. Okay, can we do 101 first? 101? Joe reads that 1 out of 4 eggs contains salmonella bacteria. Dang, okay, I eat raw eggs. Okay, not anymore. So he never uses more than 3 eggs in cooking. That is stupid. Okay. All right. If eggs do or don't contain salmonella independently of each other, the number of contaminated eggs when Joe uses 3 chosen at random has the following distribution. N is 3, P is 1 to 4, and it's binomial. That one's easy? Okay, good. Okay. In the previous question exercise, the probability that at least one of Joe's eggs contains salmonella is about, now when it says at least, okay, you pick 3 eggs. 3 eggs. Okay? At least means that, okay, there's only 4 options. None of them has salmonella. Good for you. Only 1 of them has salmonella. Not good for you. 2 of them have salmonella. Really not good for you. 3 of them have salmonella. Diarrhea for 3 weeks. Okay? Not good for you. Okay? Now, which one is it that you want? At least one of them. Huh?
I don't know.
Okay, so that means that you want this one, you want this one, and you want that one. Okay, so far? So you just go 1 minus 0. Yeah, so options are this. Okay, so this one over here, it's just binomial, PD or CDF. Doesn't matter. There's only one column, you just use PDF if you want. N is 3, P is 1 over 4, and X is what? 0. That gives you this one. If you want to find the other 3, what do? 1 minus that. Okay, here you go. Mark, you good?
I did binomial CDF 3, 0.35.
Yeah, if you use binomial CDF, okay, 3, 1 over 4, 0, are these 2 values going to be the same or different? Same, because CDF means you go from 0 to wherever X is, right? So you start at 0, you end at 0. That means you're only doing the first one. Okay. Right. And then you go 1 minus that, it gives you the other 3. Good. Okay. Next one. Shreya, go ahead. Same one as the one before chapter 9 one or another chapter 9 one? Okay, I don't know what the 9 one is. I think it's this one. Okay, which other one? 14. 14. This one here. Derive the equation for standard error on the distribution sample means and sample portions and show your work. Okay, this one over here, if you're interested in the math, I actually have it in the PowerPoint. But in the meantime, if you want, let's do it together if you want, okay? This one over here, life will test you. No, I don't know. We don't test you these things. It's not a very mathematical course in AB Stats. In case you're wondering, okay. Your sample mean, okay, let's say the population mean is X, right? No, sorry. Population mean is, I don't know, population mean is just like population mean. Okay. This okay? Yeah, this has to be equal. Okay. And then if you're looking for the standard deviation of x bar, it'll just be the standard deviation of the population divided by square root of n. This okay, everybody? Okay. Do you want me to walk you through why this is true? 1 minute. Ready? Okay. Okay. Let's say you have apples. This is my population distribution. If I'm taking only one apple, what is the standard deviation of that one apple? It'll just be like that one, right? That one apple. And then if a second apple, it'll be the same thing, but I'll call it 2. But these two values have to be what? The same. If I do 3 of them, they're all the same, okay? So let's say you have 3 of them. If I make it the standard deviation, no, hold on. Okay, that's not correct. If I have 3 of them, how do I find the standard deviation for the sum of them? What do you have to do? You have to add them all, like variance. You add them all, and what do you do after that? You square root it, okay? If you simplify this, can you see how the standard deviation for z, which is the sum of 3, is equal to the standard deviation of one of them multiplied by what? Root 3. Yes, no, everybody. Okay, this is for the sum. But right now, for sampling distribution, I don't want the sum. What do you want instead? Average. If you want to find the average for 3 of them, what do you need to do? Divide by 3. So therefore, if I'm looking for the sampling distribution of the 3, that means that I gotta take this over here, which is the sum, and then divide it by what? Divided by 3. Yes or no? So this will be equal to the standard deviation of the population multiplied by square root of 3 divided by 3. And then what cancels out? And then what does that give you? Population over square root of 3. Yes or no? Okay. So that means that you have n of them, and then you divide by n. Then what happens to square root of n and the n? They cancel out, and then you have population over square root of n. Make sense so far? Okay. If you're interested in the proportion one, it's also in the PowerPoint. Okay. Okay, everybody good with this? Okay. This is more like the math side, but we can do more if you want. Any other ones? Yes, Isabel. What do you mean? Let's just say whenever you ask that question, the answer is everything's fair game. Okay. What's that? Okay, I'll walk you through the PowerPoint. It's also in there too. Just bear with me. Let's go. Okay. Okay. Proportion is almost the same thing. It's just x over n. Okay. The number of success divided by n. Okay. Okay. Everybody good? All right. In the meantime, should we start lesson online stats notes? Wow. Okay. How much time do we have left? 25 minutes. Okay. Amber, you okay? Okay. Did we finish 10.1? Okay, we're done. Okay. We're now moving on to something different, but something useful. T distributions. Okay. So now remember this. Z distributions are only used whenever you have what again? Excellent. The population standard deviation. But the problem is in real life, you don't have that. That makes sense? So instead of using a Z distribution, what do you use now? A T distribution. Does that make sense, everybody? So right now, moving forward, you need to know when you use a T distribution, because if you ever plan to go to stats, that's something you will always use. Okay, here we go. Can I skip this one? This is just, making sure that you understand the basics. 25 minutes left. Let's move on. Okay. Okay, here we go. Okay, conditions for constructing a composite interval. Okay. Now, remember this. In order to construct a composite interval, it needs to be what again? What does it need to be again? SRS stands for simple random student sample. Thank you. Okay. Number 2, the sampling distribution must be normal, not the population. Okay. How do you ensure the sampling distribution is approximately normal? Two options. Either the population is normal or the sample size is what? 30 or more, okay? And this is only for means, okay? Sampling distribution, the sample means, okay? Last one is independence, okay? The individual observations must be independent, which means that each observation is independent of one another. That's number one. And second of all is, which means the 10% condition if we're sampling without replacement. Now this part over here, can you put this down? This is something that I found in one of the textbooks, okay? Which means the 10% condition if we're sampling without. Okay, this part is used because when you're sampling in real world, you don't put replacement. So what they're saying is you need to make sure that the sample is less than 10% of your population, just so that you can use this formula. What is that? Okay, this formula can only be used when your sample size is less than, again, 10% of your population. Okay. Okay, just making sure everyone's good. Okay. This one here, my suggestion for you is you can do some reading on it too. Okay, Google search it, ChatGPT, whatever it is. Okay, so do what you need to do. Okay. Okay. And then now, if you don't have these conditions, that means your sampling distribution is not what? It's not normal. Therefore, can you construct a confidence interval? No. Make sense? Okay. That's why the sampling distribution, it's important that it's normally distributed. Otherwise, you can't do any of this. Make sense? Okay. Okay, let's move on if you're ready. 25 minutes, eh? Wednesdays are short. Okay. Wow. 20 minutes now, eh? 15? 17 minutes. Okay. All right. We won't finish the course. It's okay. All right. Good luck, everybody. Peace out. Yeah. It won't affect me. No one cares. Yeah, it's you guys. Yeah. Yeah. You lose money. Yeah. Okay, here we go. Okay. Now, ready? T intervals. In this section, you will create a confidence interval to estimate your population mean. And the key thing is this: when the population standard deviation is unknown, you don't have the population standard deviation. Therefore, you need to replace it with what? Your sample standard deviation. Make sense? Okay, here we go. In 10.1, you have the population standard deviation. Okay, therefore, use your Z interval. But in 10.2, you don't have it anymore. You don't have this population standard deviation. So the next best thing to replace it will be your sample standard deviation. Make sense, everybody? Okay, so here we go. So if this you don't have, okay, you can't use a normal distribution anymore. So what do you use instead? You can't use a Z normal distribution. So therefore, use something called a T distribution. Now, I'm not making this up. So I asked the professor one time, why did they pick the letter T? And the reason why they picked T was because S was already used. So they decided, you know what? No S, use T. And I thought, you telling me that if T is already taken, you use U? Yeah. Okay. So therefore they call it T. Right? Okay. Make sense? Right? Okay. Anyways, T distribution. Okay. So your formula would now be equal to this. Sample mean, right in the middle. Okay? Right in the middle. And the hard part now is this. Instead of using a Z score, this part you're gonna copy down. You're using a T score. And the T score is used. Okay. Now, in order to find your T score, there's two things you need. Think of this. Okay. You need something called the level of confidence, and you also need something called your degrees of freedom. This part over here, when I first taught it, I spent a long time trying to find out what the heck is this? And then I realized, you know what? It's stats. Don't worry about it. They say use degrees of freedom. We'll just stick with it, okay? This part over here, it gets messy after a while. Degrees of freedom, okay? Your degrees of freedom depends on your sample size. And I'll give you the formula for degrees of freedom. So two things you need, okay? So degrees of freedom is equal to your sample size minus 1. Okay? That you need to copy down. In general, when I look into it, this is only a simplified version of what the degrees of freedom. When you move on to more advanced stats, there are formulas that shows you how to actually calculate degrees of freedom. Yeah. What do you think goes here? Anybody? It will be your S. Thank you.
Confidence level in the.
Say it again.
Confidence level.
Confidence level confidence, yeah, like 90% confidence, 99% confidence, 67% confidence. Okay. Okay. And then your T critical score, if you ever need to find it. Okay. Oh, by the way, who has a TI 83? Oh, you do? Okay, only you two, right? Okay. If you don't have a TI 84, you don't have something called inverse T. Inverse T, the whole purpose is you have an area and then you have your degrees of freedom, and that will give you your T score. Okay with that? Like this is the area, and then I think this is the degrees of freedom. Without inverse T, you can't find your T score. So what you need to do instead is you got to write your own program. Okay. And I'll show you how to, like, in the past, I got everybody doing it. Okay. Like if you want to move forward, you should probably learn how to do this. Okay. So I will show you how to get your inverse T. Okay. Just bear with me. Shreya, go ahead. Which we're talking about. This part over here, this is what a T, okay. Instead of using a Z score, you're using a T score. Okay. And I'll explain to you what the heck that is. Okay. For example, if it was normally distributed, if you want, let's say, a 68% confidence, how many standard deviations do you want? 1. So that means your set score will be 1. If you want, let's say, a 95% confidence, then how many standard deviations do you want? 2. Okay, so far? Now, the only problem is we're not doing Z anymore. We're doing something called T distribution. A T distribution, the difference is, depending on your sample size, the tails will be bigger. Okay, meaning that 68% now would require a bigger number of standard errors. Okay, so number of standard errors will be different. The number of standard errors you want, same kind of idea. How many standard errors you want, okay, or how many standard deviations you want, okay, or how many standard errors you want. Okay, I'll walk you through. Okay, here we go. Using TI-83 to find your critical T value. Newer graphing calculators have something called your inverse T. Can you go to distribution and look for inverse T? Inverse T, important. You need it to do well in the AP exams, okay? With inverse T, you have 2 things you need to know. Left area and degrees of freedom. Okay with that? If your graphing calculator does not have inverse T, I uploaded the link. I looked through a whole bunch of them. This is the easiest one. Okay, the easiest one to program it. Okay, this one you should do. I'll go buy like a new one. I'll let you borrow it. Anyone has it. Okay, and maybe see if I have some new one. Okay, who else doesn't have a TID4? Sure, then. Okay, I'll see if I can get you one too. Okay, yeah, or just try and program it first if you like. Okay, and in fact, everybody, when you get home, my suggestion for you is, can you go home and try this? Just learn to program it. It's actually useful to program on your TI-83. Okay. Anyways, I'll move on from this. Okay. Here we go. To find your critical T value. Critical T value again is basically when you have a sampling distribution, and in this case, because you don't have your population standard deviation, you're using what again? Your sample standard deviation. So that means that standard error is equal to S over square root of what? Your N. This is your standard error. Okay with that? And then your T score is just basically how many standard errors you want. Okay with that? It's just that, hey, if you want like 95%, your T score will be bigger or smaller. It's not the same thing as 1 or 2. Okay? So the left, and then another thing is this. Whenever you are finding your critical T score, the left area from the level of confidence. What that means is if you want a 95% confidence, the middle is 95%. What's the left area going to be? What is it? 2.5%. Everybody do me a favor right now. Okay, suppose your sample size is 30. What's your degrees of freedom? 29. Can you go right now? Inverse T, 0.025, comma 29, and tell me what your critical T-score is right now. Go. Just keep in mind that the level of confidence is always going to be the area in the middle. Okay? No, it doesn't matter, right? You're going to go plus or minus, right? Yeah, so the same thing. Good question, though. Yeah. What'd you get? 2.04. 522. Okay, good job, Mr. Straight. Yeah. Okay. So therefore, if you want a 95% confidence, is 2 standard errors enough? No, you need more than that. You need 2.04, whatever, 5, whatever number of standard errors. Make sense? Okay. So that's what the T-score is. How many standard errors you won't need to have until you have a 95% level of confidence. Mark, you okay? Looking kind of awkward. Yeah, you're like, okay, just make sure you're fine. Okay. Something happened? All right. Okay. Yeah. I know you didn't know this? Okay. Linear. It's a linear. Yeah. Mr. Yeah. Okay. Okay, here we go. Things need to copy down. Degrees of freedom is always your sample size minus 1. Whenever you're doing a confidence interval with one sample. With 2 independent samples, the degrees of freedom will be different. Very different. Okay. Oh, by the way, table C. Okay, how about this? If you don't have a T84, that gives you inverse T right away, learn to use the table C. Table C is for getting your T-scores. Okay. Everybody, can you go home and print this out? Table C. Okay. It should be available on Google, or I'll put it on BC Math for you guys. Okay. Or Teams is also table C. Right. Okay. Anyways, the problem is this. You don't. Okay. I think of all these I've looked at all the past AP exams, there have been like once or twice where there were multiple choice questions that actually does require the use of a table C. Okay. So what that means is you should learn to use it. Ready? Okay. Okay, by the way, copy this down. You don't have the values for every degrees of freedom. So therefore, you should use the next smallest one. Meaning, let's say your sample size is 60. 60, okay? What's your degrees of freedom? 59. But look at the chart, there's no 59. So what that means is you go to the next one. So if there's 40, you use 40 instead of 59. Okay? So depending on what degrees of freedom is available. Okay, I'll show you the chart if you want. Make sense? It'll be okay? All right, let's move on. Here is your chart. Oh, okay. On the left over here, these are all the what? Degrees of freedom, okay? And then over here, these are all the what? The upper tail, okay? Upper tail, which is the same thing as the left tail as well, okay? So let's say if I wanted degrees of freedom of 90%, 90%, okay? My sample size, let's say, is 40. Okay, what's number one? What's my degrees of freedom? 39. What's the area of the tail? Decimal form. Number 2 is the area is 0.05. Yes or no, everybody? Okay with that? So afterwards, I need to find my T-score. Your T-score, okay, according to this is there degrees of freedom of 39?
No.
No? Okay, can I use 40 or 30? Okay, you're going to be using either this one or that one, okay? Either one. But since you're supposed to use 39,
Closer to 40.
yeah, but it says you're supposed to use the next smallest one. So therefore, what do I use? Use 30. I'm so sorry. Use 30, okay? Okay. Next thing is this. If I use 30, what's the area of the tail again? Is it going to be 1, 2, 3, 4, 5, 5, or 6? 5, right? So that means your T-score should be about 1 point. No, 1 point. Can you see it?
6, 9, 2.
6, 9. Is it 7 or 2? It's okay. I can't see. 6, 9, 7. Can you do this in your calculator now? Inverse T. 0.05, comma, 39. And what is your degrees of freedom? Close enough?
At this point.
Close enough? Yeah, because 40 is 1.684. Okay? Your calculators will always be the most accurate. Tables are always rounded, so they'll be less accurate. Okay? Okay, everybody, can you spend like 5 seconds, talk to the person next to you if they understand what inverse T is and how to get it and so on? If you okay? Yes? Feeling better now? Okay, all of a sudden? Okay. All right. We okay? All right, here we go. Use table C, whatever. Use your graphing calculator. Find the T-score for each one of these. Go. Here. That's it. That's it. You take this one. Here, Sean. Here, just grab this. This one may not work. Yeah, just use this one. Yeah, yeah. If you ever like want to give up your graphing calculators and donate to the math department, I'd be more than happy. Yeah. Okay. Anybody want to like? I'm. Okay, first one, inverse T. What's the area going to be on the left side? 0.05. What's your degrees of freedom? 4. What'd you guys get for the T-score? So T-score is, we got 2.132. Is that right? Okay. Does it have to be positive, negative, or anything? Doesn't matter. Okay. Plus or minus the same thing. Okay. Everybody get the same thing? Can you check each other, guys? Some look around the room. Some of you like this. Is everybody okay? Okay. Arnold, you okay?
Great.
Great. Okay. Are you sure?
Yep.
Okay. All right. Okay. All right. The second one, inverse T. Let's do this together. Area. 0.025. You remember you take 1 minus this and divide by 2, right? Yes. Okay. And then degrees of freedom? 44. And what'd you guys get? Okay. Anyways, who got this? 2.01. Okay. And the last one, okay, degrees of freedom 89, 2.6322. Yeah. Easy, everybody. Okay. If I give you anything on finding T-score, again, it's a freebie. Okay. Yeah. David, you okay? I'm gonna record all your faces moving forward. Yeah. All right. All right. Here we go. 2 minutes. Who's like, Michelle, just by looking at this, I have complete confidence in being able to do this without any question, difficulty, or struggle. Hands up high. Okay, who's like, Mr. Young? I like to feel like that, but unfortunately, right now, I don't feel like that yet. Okay. Would you be able to help me walk me through this one? Because I would like to get some guidance. Yes, no? Okay. Number one. How many data points are there? 5. 1, 2, oh, sorry. 1, 2, 3, 4, 5. Number one. From now on, whenever you're looking for standard error or confidence interval, you always use your graphing calculator. Okay with that? Number one, 1, 2, 3, 4, 5. What I want you to do is type in L1. L1 will be 560, and then you put all 5 points. Sure, go ahead, yeah. Let me see first. Yeah. Yeah. Okay, put everything in, okay? Everyone okay with that? All right. Number 2, ready? I want you to do a one variable calc and tell me what your standard deviation is. Yeah. I think it should be 74.726. It's just a standard deviation of the 5 data points. Okay, don't use that. Sorry, use the 74 from. Yeah. Okay, what is the standard deviation of these 5? Oh, okay. You're so amazing, okay? What's the standard deviation equal to? 74.1. 7269. Okay, with this, okay. If I'm looking for standard error, it will be no, remember, you're looking for t distribution, right? So therefore you go 74.7269 divided by square root of what? 5. Tell me what this equals to. 33 point something? Okay, in that case, you know what? Use the other one. What's the S equal to? 83 point what? 83.55? 83.55? Can you take the 83.55? 83.55 divided by square root of 5? What would you get? What's that? 37.36. That S represents your sample standard deviation. So I guess is this one? This is the question that uses distribution because the population, okay, therefore sample size is 5, degrees of freedom is 4, confidence level is 95%. And then if you here, let's just do this instead. Here, I'll show you how to do this properly. Okay. Can you go to your calculator and just go put this in L1, go T interval, your data set in L1, frequency is 1, 95%, and then I want you to press calculate first. Just do it quickly first. We'll get to it. It's the other value, the S, remember? What you guys get when you use calculate? Who got, okay, if you're gonna use data, make sure data is stored in one list. And who got this over here? Okay, you guys okay with that? And then over here, this is your confidence interval. Okay, and which one's that one right now? It will be A. Okay, so far. And then B, this over here is your. Okay, hold on. Sample standard deviation is 83.546. If you want to find your standard error, what do? You take this number divided by square root of n. So 83.546 divided by square root of 5. And what does that give you? What's that? What is this over here? What is this over here? You mean, can you see calculate? Okay, this with S, sample standard deviation. And then this over here, I guess it's supposed to be your population standard deviation. Okay, so use this one over here for standard error because you don't have your population standard deviation. Yeah, they want you to use this one.
What is the other one for?
Population. Yeah, because I guess it's sample and the population, so therefore we use this one.
Why do you get two different numbers?
If it was a population, use this one. If it
Why
was
is
a
the
sample,
dimension different?
oh, so you go from that. Here, you want to see it? There. Okay. If it was a population, it is the average of the variance divided by n, right? If it's for sample standard deviation, you have 1 degrees of freedom. So instead of divide by n, divide by n minus 1. So therefore, the value will always be bigger. Okay? You sure you guys?
Yeah.
We're trying to take advanced algebra next year, right? Do you put it on my advanced solution or just
Just make sure you put it in your the question form, and then I'll make sure you're in there, and then
yeah, we're trying to take it at the time, like